Hello and welcome to another lesson that is part of the TI-30XB student course. In this lesson, we will use the TI-30XB to help solve a trigonometry problem requiring the use of Pythagoras' theorem. Note that when solving three-dimensional problems involving Pythagoras' theorem, which the example that we're going to do is, it is important to draw carefully labelled diagrams identifying the right-angled triangles where the theorem can be applied to find unknown lengths. So for this example in particular, we're going to solve a problem involving the lengths of the edges and diagonals of a rectangular prism, or simply put, a rectangular box. So let's examine our example. We're going to use the TI-30XB to help us find the length of a straw which will fit diagonally into a child's fruit juice box and extend out of the box by 2 centimetres, so they're able to use the straw to drink. And we're going to give our answer correct to 1 decimal place. So first of all, let's have a look at our three-dimensional diagram. And the base is rectangular, 10 centimetres by 5 centimetres, and notice that the height of the box is 15 centimetres. We have a straw that's inside the box, and note that extends out by 2 centimetres. So first of all, what we're going to do is we're going to form a right-angled triangle with the base of the box. And so our two perpendicular sides are going to be 10 centimetres and 5 centimetres, and we're going to let the hypotenuse be x centimetres. So our first goal here is we're going to find x. So what we do is head to our calculator. We're going to press 10 and press the x squared button. So we're using Pythagoras' theorem. We're then going to press plus, or the addition key, enter 5, press x squared again, and then press enter. So basically what we've got so far is that x squared is equal to 125. Now let's form our second right angle triangle, and it is formed in this way. It's using the hypotenuse of the triangle that we formed with the base, with the height of the box, with the straw as the hypotenuse. So this is our second right angle triangle. We're then going to find that distance, or the length of that hypotenuse, y, and then as a final part of our calculation, because the straw is sticking 2 centimetres outside of the box, we're going to add 2 to our value of y. In other words, the length of the straw is considered to be y plus 2 centimetres. So let's now find the value of y. And what's really nice here is that we can incorporate the calculation that we just performed. So we now can form the equation y squared is equal to x squared plus 15 squared. And we know that x squared is 125. So in effect, y squared is 125 plus 15 squared, which is 225. You add those two numbers together, and y squared is equal to 350. Y, therefore, is equal to the square root of 350 in exact form. So what we're going to do is we're going to press second x squared, and that pastes the square root symbol onto our screen. So we're now finding the value of y. We now press second and the negative sign key. We then press the addition key. We then press or enter 15 and then press x squared. So what we have in here is we have the square root of 125, the previous answer, plus 15 squared. We now press arrow to the right to move the cursor outside the square root sign, or out from underneath the square root sign. Now remember, we had to add 2 centimeters because the straw is sticking out by 2 centimeters out of the box, so we go plus 2. Now the question asks us to express our answer correct to 1 decimal place. First of all, we can now press the toggle key, which is going to give us an answer in decimal form. Then press enter, and we end up with a length of straw of 20.708, etc. centimeters. So correct to 1 decimal place, the length of the straw is 20.7 centimeters. Okay, that's it for this lesson. Thanks for watching, and bye for now.